Okay, so next we move on to today's speaker. Today's speaker is Jisheng. He's a personal friend of mine. We met back in MMU when we're doing postgrad together. I consider him as an all-rounder expert, technology strategist, as well as an amazing solutions architect. You can ask him anything you want about AWS, IoT, web, mobile, DevOps, machine learning, AI, data science. He can answer you. He can really, really answer you. Okay, I will save time on the introduction today because today is an info-packed and long session, 2 hours. Hope you guys had a full meal because you have a lot of questions to ask later. Okay, you can read more about him in the event's description. Without further ado, I will pass the stage to Jisheng. Take it away, eh?
Okay, thank you, Darren, for the introduction. Hope you guys can hear me and you guys have already eaten your dinner. And this is going to be a long session. How long it will be? I don't think I can finish everything in 2 hours, but I try my best. We'll be giving you a lot of information in terms of what is going on in the blockchain space. So yeah, let me share my slides. How do I change my slides?
Okay, you can share the screen button at the bottom.
Already shared, but I think it's not pinned to the top.
Okay, let me add to stream. All right, there you go.
Okay, there I go. So yep. Okay, so here's the exciting things that is going to happen today. So this year itself, we have saw Bitcoin hitting the high of 63,000 US dollars. That is something that you can never imagine. What you don't imagine that last year the lowest low was 3,000 US dollars per Bitcoin. So what exactly is Bitcoin? What exactly is blockchain? Why people link them together? So today we are going to have the sessions that is going to talk about this. So after seeing the high of 63,000, now we see that it suddenly goes down by just tweets of Elon Musk saying that environmental worries, and then some rumors and news that talks about Chinese try to crack down on illegal Bitcoin mining. So the word illegal is very important. So if you're legal, you don't really have to worry about it. So we also saw that Visa announced that they are going to support transaction settlement with US dollar coin, USDT, USDC. Sorry. So it's a coin. Then MasterCard also comes into play and say that, yeah, they can. So Bitcoin drops after Elon Musk tweets again. So just few hours ago, Elon Musk tweets again. So this time with a broken heart and a hashtag of Bitcoin. So people will say that Bitcoin is a store of value, but why is this value being affected by tweets, being affected by people? So this is something that people who like to discuss a lot. But today's session, we are going to be slightly different. We don't want to talk about the price hype so much, but much more into the technology behind it. So another very interesting concept that came up is about NFTs. So this art itself from an artist, a digital artist named Beeple, has already gotten 69.3 million US dollars in the auction. So this is the artwork that he started in 2007. So 5,000 days, one day, one picture. So he committed to actually draw one picture every day and has continued drawing for 5,000 days. So that collage of these 5,000 days becomes an NFT. So what is NFT itself, we can discuss later. So it becomes an NFT and actually sold for this much amount of money. So it's a picture that is very, very, very large. It contains of a lot of digital arts. So that is how the value actually derive. So these two things called as the CryptoPunk. So CryptoPunk itself is a random 10,000 piece of art or piece of avatar that is being generated through random algorithms. So the Alien series is very rare, and because of that, people actually auctioned it, and these two arts is being sold for 7.55 million and 7.56 million. So it's something about collectibles. So we'll look into that as well. So just a disclaimer before we continue saying anything. So I'm not a financial planner, financial advisors, nor am I a certified financial analyst, nor an economist, CPA, accountant, lawyer, or anything. So what I'm sharing now is totally makes no financial professional formal education sense. So take it as your own reference and do your own research before you invest in any cryptocurrencies, because it is not illegal to buy and sell Bitcoins in Malaysia. There are regulations already, but I still have to say this because two years ago, it was totally semi-dark area. So this is a disclaimer. So just do your own research. So blockchain, what is that actually? So let's find out. So a common misconception on blockchain. So many people think that blockchain means Bitcoin. Yeah. So when it thinks about blockchain means Bitcoin, they will say that Bitcoin means pyramid scheme. So they will just disable this whole thing and say that, yeah, it doesn't make sense. So another big misconception from people is that cryptocurrency is blockchain. So not really all cryptocurrency is blockchain. So we have to find a way to really understand. So what is the actual fact? The actual fact is that blockchain is a technology. Bitcoin is just an example of it. So not all cryptocurrency are using blockchain technology. If you go down deeper and find that most of the cryptocurrencies, some are using some other technology and all that, and not really entirely focusing on using blockchain technology. Some of them can be distributed ledger. Some of them can be different mechanisms, different way of actually helping people to have some sort of like a tokenomics behind. So not all cryptocurrency is actually using blockchain technology. So blockchain can in fact store some other data, including files, and even actually run scripts. That's what we call smart contracts. So before we dive deeper into what is blockchain itself, we can look into RAI stones. So these stones itself, why is it so special? You can go and check on Wikipedia. You can actually look into it. These stones itself, in the earliest reports by the Western European, is that in around 1,700 years, that means 300 years to 300 years, 300 plus years ago. So people started using this stone as a way to store value. So large artifacts that were manufactured or being crafted. So they found these stones and then they craft it and then they put it on the island. So when you want to actually make a value transfer, you will have to be a special occasion where you ask people to come and witness. So you will take a chalk and just cut off your name and then put the new owner's name on it. So you can visualize blockchain as some concept like this, where every single value transfer happens by broadcasting or telling people that I'm sending this portion of the tokens to another person or another address or another entity. So this is what we can see from this very ancient way of open distributed ledger, where everyone can come here and see that, that is the ledger. So this stone now belongs to this guy. So this guy is wealthy. So the bigger the stone, the bigger the value. So this is how it works in the island. So RAI basically just means whale, also means whale for the tribe that use this method to actually store value. So basically we can see why we call, in crypto, we call it whale in and whale out when you have large transactions. Okay, so this is actually how to read a Bitcoin transactions. So since when I designed the talk today, I try to make it that so simple that you can still follow through, even though you are not looking into cryptocurrencies or blockchain technology. So just to let you know how Bitcoin transaction looks like. So this is an example of it. So some address on the left side. send a certain amount of BTC or Bitcoin to some address on the right side, and then the balance is written in another address. So we can then tell that, okay, 3HA is somehow sending to 3AW, and 3L1 might be the balance that is returned from this transaction. So this transaction itself is transferring about 690 million US dollars, or 1.1 billion at the time of this transaction happens. So how can you transfer 1.1 billion in one transaction? So this is something that Bitcoin enables it, that you can actually send cross-border and all that with the fee of 67 cent US dollars. So a relatively cheap, and it's something that is the government cannot stop you, the bank cannot stop you. It happens just within 10 minutes, and your Bitcoin is already transferred. So this is how blockchain has already changed the ideas of value transfer. So when we are looking deeper into blockchain technology, we will have to look into a centralized ledger and a distributed ledger. So the banking system today is, we could say, is centralized ledger in the sense that we have a clearing house, and you can see that the clearing house is like the main branch where all transaction happens, and then there are a lot of different banks. Or we can call this central clearing house as the SWIFT. So when you want to send funds from one country to another country, you will have to go through this SWIFT that actually clears the transaction. But for blockchain, for distributed ledger, you don't have to do that. So once you broadcast the transaction, it's being recorded in every single node that run the same consensus mechanism. So the same mechanism, the same blockchain, they will be copied to all the nodes or all the miners or all the computers that actually run this. So these words itself can be interchangeable and can be non-interchangeable depending on the situation. So maybe we can talk about that later. Okay, so there are some characteristics of blockchain that we want to look into today. So one thing is that the immutability of the data. So the data itself can be immutable. So what does it mean to be immutable? It means that when the transaction is stopped, nobody else can actually go back in time and change. So that is the immutability of it. The timestamp of the transaction. Every single transaction on a blockchain can be actually timestamped. So if I transfer my funds to another person, the information is immediately recorded in the blockchain. So the timestamp will be there. Then traceability. So how do we ensure traceability? Like the ledger example just now, we can see that these funds actually come from this address to this address. So we can trace it back. And you can always go back all the way until the formation of that particular Bitcoin. So that is the traceability and transparency. So in this case, transparency is achieved by the transaction example earlier. So we can see that is transparent. We can see that transaction happens, but we might not know who is that address unless they voluntarily tell you, or you have some ways to trace it back. For example, if I am sending to another person, so that person should know that I am the one sending. So in this case, the privacy is not there. Okay. So executable codes. So this is the part that makes blockchain expansion bigger and bigger day by day. So how can we how can this achieve is that in blockchain like Ethereum, in fork of Ethereum like Ethereum Classic, Binance Smart Chain, Heco, and all this chain, they actually have this virtual machine. So they call it EVM, Ethereum Virtual Machine, or we just call it virtual machine. In this case itself, we can define that a transaction is no longer just a transaction. A transaction can be executing a certain function. So how can we write this function? How can we store this data? All this thing is really depending on the organization that wants to use it. Okay. I see a lot of Q&A coming, and I think it's a very good question. I wanted to answer them, but then I think I will just follow through and go through first, and then we can have one round of Q&A before we go for the coding sessions. Okay, so in what situation we can use blockchain, and in what situation we don't want to use blockchain? So we have to ask ourselves a question. Do we need to create trust? Do we need to have the transparency? If these two, yes, then we can actually consider blockchain. So blockchain is slow in terms of confirmation time. If we are trying to send some coins over or something, we can see that the confirmation time actually takes some time. So it's not as fast as we think. And then it can be expensive. Expensive in the sense that it will take you some time. It will take a lot of nodes to copy the same copy of it. So if I am recording, say, ABCD, and it can take only very few bytes. So in this case, this 3 bytes is being copied to a million, for Bitcoin, for example, a million nodes in the whole world. So these 3 bytes will become 3 million bytes. So it can be very expensive in this case, and it's not easy to scale. A lot of different blockchain projects try to scale their products, but then they are not able to do this. So so different people came out, different projects came out with different scaling mechanism. So another thing is user experience. In order to achieve mass adoption of blockchain technology, the user experience is really very important, and we have to find a way to see how to actually get the whole concepts or the whole things to be very easy to use, especially non-technical people. How can we let them adopt this technology? Okay, so there are a few key concepts in a blockchain, in a typical blockchain technology. One thing is that it has to be a distributed ledger. So you have to have some mechanism of storing or recording data. Then it has to be peer-to-peer network. So not just one people is storing the whole thing. It can be spread across multiple nodes, multiple computers. So there have to be some sort of validity rules, whether you can transfer. If you don't have the funds, you cannot transfer. So a validity rules needs to be stated. And then a cryptography. That means how can we actually use cryptography to make this thing, how do we make this blockchain secure? So some sort of cryptography have to be included. So it's either hashing, or is it a private and public key mechanism, or there are even more sophisticated cryptography that is coming out day by day. And last but not least will be the consensus mechanism. So the consensus mechanism meaning that how do we come together and say that this is the final blockchain. So that is the finality and the consensus. So if everyone agrees that this is the latest block, this is the final block, then that is considered as sealed. So there are hackers, there are bad players. So how do we use a better consensus mechanism to actually overcome that? So looking at all this, if you are thinking that, oh, a blockchain developers have to do all this thing, that is actually something that is very hard to achieve. So we have to look into another thing. So in web development, we have a full stack web developers. So full stack web developers meaning that you have to know that, oh, HTTPS, this protocol, how do we structure it? And then we want to look into networking. How do we prevent people from DDoSing? So the networking layers, and then the application layers, which is actually where we build the APIs, where we build the web interface and everything. So same goes to blockchain development. People that is on the protocol layer will have to look into different types of consensus mechanism, different types of cryptography, different types of validity and everything. So that is the protocol layer. And then the networking layer, how do we make the P2P works faster, synchronize, and get finality and all that? But most of the time in the market, we are only seeing at the application layer. So meaning that how do we get our smart contract to be out in the whole system? How do we make it different compared to other people? So personally, I'm going to share what I have done and a little bit of what can we actually use it later. So there are a lot of questions in terms of how is it a public blockchain, how is it a private blockchain, how do we define different types of consensus mechanism and all that. So what I did in the past 3 years is that I contribute to a public blockchain protocol. I came in about 4 months after they launched. So it's TRVC, the Trichain. It's now legacy now, as we are moving to be much more on the token base, and how do we further the tokenomics instead of the full development stack that is very heavy to maintain and very expensive to maintain and very time consuming. So what we have achieved is that all the tokens have to be mined or have to be created in 3 ways. So one way is actually the proof of work way in the center here. So this is the proof of work way, where we use an algorithm to calculate the hash and then to mine and make sure that the blockchain is final. So that is the way proof of work work. Usually they will be mined by either graphic cards or by certain ASIC that is predefined and only runs that particular function very well. So that is the proof of work that we usually hear that is very hot, it's very energy inefficient. It will be eating up the whole city worth of electricity and all that. So that is the proof of work that we know. But besides that, there are also other ways that you can actually secure transactions. So that is actually a proof of service, or some of them call it proof of stake. So proof of service and proof of stake is 2 different things. So proof of stake requires you to stake your tokens and make sure that you will continue providing confirmations, providing finality of that blockchain. But for proof of service, you will have to run a dedicated server. We call it as the master node. So in this case itself, it also helps to facilitate or helps to create a copy of that particular blockchain. So the third way you can get these tokens back then in 2018 until 2021 is that the voting and budget system. So we incentivize developers to build on that particular blockchain protocol because we know that it's very heavy. So we came out with the budget allocation ideas. So besides that, we also achieved 2 different types of tokenization ability. So a fungible assets, meaning that you can tokenize your own tokens, and a non-fungible asset means you can tokenize something that is non-fungible. That means they are not equal. So we'll see some examples later. Okay, so we have built the App Store, which is part of the apps that allows you to actually submit your games and allows people to play, as we are a games and entertainment protocol. But we continue to try R&D different use cases out of the blockchain. So one of the use cases that we find very useful, or something that can make use of the immutability of the blockchain, is this example. So what happens is that we copied the data from SPRM website, and then we store it on the blockchain as an open data. So anyone can look back into the blockchain and say that, oh, on this point of date, on this date and this time, this minister actually declared this amount. So this thing cannot be changed unless the whole blockchain is vanished or being removed. So another use cases that we have is the Thrive credentials. So Thrive credentials are also known as Thrive stamping earlier. So what we do is that we take the file and along with the hash, the metadata, we store it on the blockchain. So anyone can actually verify the documents. So since we accept metadata, that means we can accept almost anything, not just pictures. But in this case, pictures, so other people is easier to understand the concepts of it. So we have done it with one of the event in Malaysia. So it's called the Blockonomic, Blockchain Economic Forum. So Blockonomic. So we have done the certificates of appreciation for everyone that came as a participant, as well as the volunteers, the speakers. So not participants, only the speakers and the volunteers. So they get their own dedicated certificates, so they can verify their own blockchain, including IPFS, where the files are actually stored. So we have also came out with an idea that what can actually blockchain do. So in this case itself, Durian, we realized that no land authority can actually tells you that this land is being subbroken into how many plots of trees. So in this case itself, this can be very useful. Say it's like a virtual garant where if you hold this NFT or this non-fungible asset, you are the true owner of this certificate. Sure, there can be disputes and all that, where the owners can then reissue the certificates and all that. But the idea of having a non-fungible token or non-fungible assets is that this will then helps you to actually verify that the owners, who is the owner and all that. So besides that, in one of the events in IIUM, so we went there and actually gave a talk. So we help all the students to actually scan their certificates and put it up. So at any point of time, they can then see on blockchain that this is my certificates. Okay. Besides that, games. So if you do a game, you don't want to pay App Store, Play Store to 30% to actually get your take a cut from your game, then this is actually an alternative. That means accepting cryptocurrencies. But sure, please pay your tax if you're doing this. Okay, some games, this is not so halal. Certain level of gambling elements in it. So these are the games that community has built. So basically, every block, the block hash is unique. So they use the last few elements of the block to decide the character, the last element. So in hexadecimal, it can be from 0 to F. So there's 16 possibilities. So 16 different characters. So this is how they actually use it. And then 2021. So this year, what has changed? There are a lot of things that is changed. So we'll look into it. Okay, so this is one of the things that is changed, DeFi. We have here DeFi or decentralized finance a lot this year. So DeFi, what is DeFi and what is it that people is looking into? So number one thing that is changed is the DeFi liquidity pool. So liquidity pool meaning that anyone can be money changer. Today, imagine if you are shopping on the shopping mall and you see a money changer. So what can this money changer actually do? They take a lot of different people. Most probably they have a group of people supplying the money. So let's say Ringgit Malaysia and US dollars. So they will then determine a rate with a margin in it, and then they actually change for you. So there's a buy and there's a sell. So they create a gap, and you cannot really decide this buy and sell price. So it's entirely up to that liquidity pool or that particular people, what is the price that they want to decide. So this is the same thing that is being brought to blockchain. So in blockchain, we can write codes. We can write executable functions that allows people to automatically call this function. So in this case itself, we have the supplier of the liquidity. In this case, you have to put in 2 tokens. So in this example, we can see that this particular liquidity provider puts in 10 token A and 1 token B to actually get 4 LP shares. So when people actually exchange the funds, they will then actually take out the shares. Okay, so we will look into that in this one. Okay, so they define a curve, and this curve actually tells you what is the current price of the token exchange. So in this example, there's 1,200 token A and 400 token B in the pool. So in this case, we can say that it's 3 token A to exchange for 1 token B. But in this case, then the liquidity provider will not have any benefits. So why should I provide the liquidity if I'm only doing the exchange? So they make this 0.03% fee. So you have to pay 3 token A plus 0.03% fee in order to get 1 token B. So in this case itself, the new price is determined immediately after you can see that the transaction ends. So the transaction ends, you will then see a new price. So this is the DeFi swap that actually make a lot of small exchanges obsolete or not important anymore, because any tokens can now be put into the smart contract and have a certain value. So this value is being confirmed and is being assured by the whole smart contract. So you can always verify that this code itself, the value is there. So besides that, another big thing that came out is the non-fungible tokens. So these two itself is the Beeple's art again. And then the third one is actually Hublot watch. So what is non-fungible tokens and what is fungible? So we have to look into what is fungible first. So a fungible token, for example, a fungible things is like Ringgit Malaysia 1. So if you have 5 1 Ringgit notes, they look different in the sense of serial number, but they carries the same value of 1 Ringgit. So in this case itself, you go to 7-Eleven, no matter which 1 Ringgit you pick, the value is the same. So in this case, this is called as a fungible currency or a fungible asset or a fungible tokens. So non-fungible, meaning that, let's say you have cinema tickets. They are all same, 8 p.m. They are all same for my live show, but maybe the seats arrangement is different. So they are the same cinema tickets, the same movie, but then the value is different. You might be sitting in front, you might be sitting behind. So this is where the value is being derived. So it's the same cinema tickets, the same day, same time, but then the value is different. So this is the idea of a non-fungible tokens. So every items in the luxury world or the collectibles world are limited and unique. So in this case itself, Louis Vuitton, LVMH, or Louis Vuitton, Hennessy, Moet, that company, they own Hublot, they own Christian Dior, they own a lot of luxury goods. They came out with their own blockchain. So this blockchain itself, they actually store all this unique warranty of the tokens, the unique warranty that is totally related to that one product. So in the future, we might see that in the luxury world, if you buy a Ferrari without an NFT, your Ferrari might be fake. If you buy a bag without that NFT, your bag might be fake. So that is how the luxury companies actually use technology to counter attack the fake and the not genuine products. So in this case itself, you can see that Hublot limited editions watch, they are the first one to put their own warranty cards into it. So the moment you buy the watch from the boutique, so this boutique will give you the NFT tokens, which is actually a warranty card that tells you that this item or this watch is genuine, is being sold on this date. The warranty covers from this date plus how many days. So in this case itself, if you were to sell this watch, you can easily just sell it with an NFT. If people don't own this NFT, they bought that watch is not the genuine one. So that is how NFT has changed the market. Okay, so back to the DeFi segment. Let's look at I don't want to look at Ethereum landscape because Ethereum landscape is too much. So let's look at the second, the biggest, most transactions blockchain, Binance Smart Chain. So Binance Smart Chain is a fork of Ethereum, but instead of using proof of work, they use proof of stake authority. That means you have to be an organization that is known to Binance. At the same time, you have to stake about 300,000 BNB to be a validator's node. So a validator's node get to confirm transactions, get to run transactions, get to create the block. So this creates the lower usage of the electricity, because if we were using electricity to count hash or to generate random hash until one matches the condition, then this is not a very good use cases of electricity. So Binance Smart Chain or the proof of authority or the proof of stake people, they thought that why not we just get a bigger server, we get only a few people that can run this. So between fully decentralized and semi-decentralized, so that is actually a very big big research, I would say, if we were to continue running it and to continue looking at it. So that itself can be one research. So we look into Binance Smart Chain because they achieve about 14 million transactions per day compared to 1.5 million from Ethereum. So that is a lot of transactions. So we have to see what is really into these transactions. So we can see from this area, the exchange and liquidity side. So this is actually the transactions that is automated to help you do a value swap or token swap. So the idea behind is the same as we saw in the previous slide, this concept. So the price is starting here. So when you make an exchange, you will see that the price actually move. So that is the way how they actually decide the price that is currently on sale. So this is actually the same idea of all these exchanger or liquidity. So you provide your funds as the initial liquidity, and whenever they want to make an exchange, they can just make an exchange with the initial liquidity that is already inside. Okay, so that's the idea of exchange and liquidity. So another question arises. So many different exchange. How do we make sure that our funds that we put in is able to earn the exchange fee that we are looking at? So here comes another idea. Yield farming. So yield farming over here, they provide you with the with a constant reward, meaning that if you put your liquidity into our protocol, and we will then incentivize you a fixed amount of tokens, so that you will not put the funds there for no reason. You will always get back something else, which is actually their project tokens as the incentive. So in this case itself is where we see different liquidity exchanger trying to get users to be on their platform. And lots of different high yield farming projects came out. Is it sustainable? I think that we have to look into it. At the end of the day, the liquidity is where you can actually make the most money. So, okay, so this is yield farming and exchange and liquidity. So let's look into stable coin. So stable coin ideas came out like USDT and all this, meaning that if you give me $1, I will give you this $1 equivalent tokens where I lock your money in the bank. So in this case, you can easily enter into the crypto world. So that is the rise of these stable coins. So different stable coins pledge with different assets. So some pledge with the gold, some pledge with US dollars, some pledge with the Chinese yuan, and so on and so on. So all this stable coin is a rise because of helping normal users go into the blockchain scene. The lending protocol, however, is another very interesting topic where you actually borrow your assets to the protocol, and the protocol will then decide interest rate. If the funds is underutilized, you will then have a slightly lower interest rate. I mean, you'll pay very low interest rates to borrow the assets. Well, if a lot of people is borrowing, so the amounts of reserve gets lesser and lesser, then you have to pay a higher interest rate. So how do we ensure that this whole value thing can be can be properly stored, and you don't lose money by lending out your, let's say, US dollars. So the idea came because of, say, today one Bitcoin is worth 40,000. So you don't want to sell Bitcoin because maybe you bought it at 60,000. So what would happen is that you can actually lend this Bitcoin to this protocol, and this protocol will then give you a maybe 60% margin. So 40,000 current price, you can get to lend 60% of this 40,000, so about 24,000 USDT or US dollar. So you can then use this 24,000 US dollars to buy on Bitcoin. Then if Bitcoin suddenly rise, then you can then sell and actually return back the US dollars that you borrow along with interest rates. So in this case itself, it's entirely decentralized. We don't have to submit our payroll. We don't have to submit our payslip. We don't have to have a very good financial background. All we have to do is collateralize some tokens, and then to get more tokens. So in this case itself is something that will change, but how it can be used for margin, it can be used for futures, it can be used for a lot of things. So it's really up to different projects, different developers, how they want to make some changes. So we have another thing, derivatives. So in derivatives, some derivatives actually mirror what is happening on the stock market. So we can see that there's actually one mirror Tesla shares. We can see a mirror of Netflix share. We can see mirror of Facebook share, Google share. So basically, we can actually buy the traditional share market price. I mean, the share market without even open a bank account. So this might be something that will change the whole trading that we already know. So last time when we want to trade to buy a US stock, for example, in Malaysia, we have to go to the bank. We have to prove that we are able to, we have a certain amount of money in the bank, because to open the cash account, you need money. And then another thing is that your funds, your money, you cannot buy just 0.1 shares of Amazon. Amazon is trading at 3,000 US dollars. We cannot buy 0.1 Amazon. We have to buy one whole Amazon, which is 3,000 US dollars, and the fee is not cheap. To do this on Binance Smart Chain, every single trade might cost you about 20 cents to 50 cents US dollars. But to do this on Maybank, for example, you have to pay about 25 US dollars for the trading fee, for the broker fee, and at the same time you have to pay some other fees. So in this case itself, the whole price is very different. So that creates another interesting thing in the DeFi space. So that is actually the main thing that most of the DeFi, or we can see this area, we just covered this area. Okay, so this area we have already covered what they are and what they do. And then now let's look into the NFT space. So previously when we play games, how do we sell our items? We have to find a friends, we have to go to a forum, we have to go some way to actually sell our items, sell our accounts. So how can blockchain makes this different? So in blockchain world, all games items are being tokenized. So they are being tokenized as an NFT, and every NFT can be used in the game. So in this case itself, if you own this item or you own this account that you play at different level very high, you can even put it up on auction hall and say, oh, I want to actually sell this, and you can actually get your money immediately. So that is actually the idea of how Bitcoin came out. So Bitcoin actually came out when, after the Pizza Day, some people say, I want to buy an account and I'm offering Bitcoins. So in this case, the first, the second transaction, the third transaction, all happens because of gamers. So gamers actually bring the value for a single Bitcoin after the pizza. So in this case itself, we can see the NFT and games. So besides that, NFT also, you can now buy NFTs of autography session with your favorite idol. You could buy NFT of their pictures, their game items as a way of supporting the team. So it can be an esports team, it can be a sports team, football team, it can be someone you like. So anyone can now be on the NFT space and then actually build NFT stuff. So games itself, I think the idea is endless. DeFi itself is endless, and it's really up to projects on how well they have or how good they have in terms of ideas of how to expand this. But all these things that we see over here is on a public blockchain. So yeah, even more in the NFT space. So if we look into NFT space earlier, we have like collectibles, CryptoPunks is here. Games itself, you can see Xe. Xe is a big game in Ethereum. CryptoKitties is the first one that came out with kitties that you can actually buy and breed. Then Marketplace is where you can actually sell your artwork. So there are some very insane artwork that is actually a physical copy. They scan it, they burn the original copy from the auction hall, and then put it up on the marketplace. DeFi NFT, how do we make NFT to have some financial in it? VR. So Decentraland is one that you can look into. They have a very cool VR place where you can even see like Atari built their own building over there, so you can play some arcade game in the VR world. So domains, I actually bought my own unstoppable domain. So it's sifujisheng.crypto. So basically you go there, it will be point to IPFS. So that is something that is quite cool. So a lot more things that you can do with NFT. So satellite network. So this is actually very interesting things that I always include. This is the latest slide that I just, this is the latest picture that I just put in. Every year since 2018, 2019, I actually put this in my slides. So when they say, oh yeah, blockchain is just another database, it can't work without the internet. Unfortunately, you can say that a few years ago, but with the current trend, it's very hard for you to say that anymore, because Bitcoin, Ethereum is already on the space, literally not yet on the moon, but then it's on the space. You can see satellite orbiting the Earth. So this satellite itself is actually orbiting and helps you confirm transaction, as well as for you to broadcast transactions to all the nodes. So you don't even need to have internet if you really want to make a Bitcoin transaction. So that is how the trend has moved, and lots of things has changed. The crypto relief funds in India raised billions of dollars to actually help their COVID cases. So a lot of interesting thing comes out. So I think there are a lot of questions, very interesting questions. Maybe we go for a Q&A before we jump to the coding sessions. Okay, I think I will need Terrence's help.
Yeah. Okay, I think that can work. Let's answer some questions.
Yeah, lots of questions I saw
I'll
along the
pin
way.
it on the screen and then you answer, and then I'll read it out for you. Let's see. First question we have is, how precisely can you track a Bitcoin wallet owner? That means, like, how do you know if this wallet belongs to a certain person, I guess?
Okay, I think we can change the screen to have without my slides.
Okay.
Okay.
Alright.
Cool. So how precisely can you track a Bitcoin wallet owner? This is a question that if I can answer you, I think the Interpol would love me to be in their office, because Interpol have been hiring a lot of data scientists, crunching through the data, trying to analyze like WannaCry hack. So after they hack the computers, they receive the ransom. How can they actually siphon out the money? So they are trying to trace. And if you look into a recent case, Binance has helped to identify one scam cases, hack cases, and they actually reports to their respective countries' police officer, helping to trace back about million US dollars. But I believe there are still a lot more thieves, hackers. They are smarter than authority, that they will just manage to siphon out the money. It can take some if the developers or the hackers actually, after they hack the funds, they immediately transfer it to an exchanger trying to sell it. That guy will be in trouble, because all exchanger actually works with authorities to actually see how they can bust them. So how precisely we can track? There's no way we can very precisely track, but it is actually easier to track than using cash, because cash, you can easily buy some nasi lemak with $10, and then you keep everything else in under your bed. So in this case itself, it's very hard to track. But for cryptocurrencies, we can easily tell that, oh, this money refers to this wallet. This wallet came from this wallet. If you don't do it a lot of times, you might actually we can actually trace you easily.
Right. So basically the wallet address is the hash value,
So,
but
yeah,
not necessarily you can tie to a person.
you can't really tie to a person, but you can tell that this address might be related to this.
So let's say I want to check on Elon Musk's wallet.
I think you can try to check on Vitalik first. Vitalik is very easy to check.
Oh yeah, I think it publicized his address, right?
Yeah, just go to Etherscan and track, then you can see his address.
Yeah, Etherscan.io, bookmark the address.
Yeah.
Okay, let's move to the next question. Next question is, can you explain the difference between public and private blockchain and when to use them?
Okay, this is a good question. I tried to fit in a lot of information into the slide, but I realized that I cannot. If I fit in everything, it will be too boring, or it will be too annoying to say everything. Okay, so basically public and private blockchains, they are blockchains, just that in the public blockchain cases, they will use a consensus mechanism that everyone can participate. For example, Bitcoin uses a consensus that is, you have to use the graphic cards, you have to run the hashing algorithm until you get the correct block hash. So that is called the proof of work. So in this case itself is public because everyone can participate. For private blockchain, they usually use something more private, in the sense that is using the consensus mechanism like proof of authority. Proof of authority don't requires you to run anything. You can just use a normal computer and set up a private blockchain with proof of authority. So you say that this address, this address, this address can mine the next block. So in that case itself, this tree will just alternate themselves. So this is a private blockchain example. And if you want something that is just among your organization, for example, if today I'm a bank, I want to use a private blockchain. So all different branch and all different people all use this same blockchain. But who secures it? The HQ of this bank secures it. So in this case itself, it's a private blockchain that everyone can participate, or maybe a certain branch can come together and mine the whole thing. So they will make a copy in every single branch, and at the same time, a few branch will be the one that actually consolidate the transaction. If we use the traditional word, we don't call it mining or mine. It can be sometimes confusing. We just call consolidation of transactions with the ledger into the ledger, and then just store them in the database forever. So to use a public blockchain, you will want people to come and actually helps you together. So you want collaborative. You want everyone to come into this space. You want the commitment from everyone. Then you use a public blockchain. If you only want to keep it within yourself, your organization with only a few maybe organization that you trust, then you can do a private blockchain. In fact, you can even hide the port and only allows these people to connect. Only these nodes can connect to you. Or some private blockchain even evolve up to a point like you will need to have a certain key in order to synchronize the whole thing. So that is the private blockchain. So in LVMH cases, they use a private blockchain. So everyone can see the data. They use a private. In terms of consensus, they are private. But then in terms of the data, is actually public. So in this case, only LVMH nodes can mine the blockchain, can create new, can consolidate transactions, but everyone can verify that this is actually the real watch, or this is the real bag that you're holding. So it's really up to your use cases, and you have to see when to use every one of them.
Right. So that means the view permission is with everyone is public, but the create permission is only within LV themselves.
Correct.
Something
So
like that.
basically CRUD lah. So create and update. Delete is not possible in blockchain. So you can create, you can update. Update is also a create. That means you create a new transactions to update the value. So basically, blockchain we can see it as a database that only has create and view functions. So you have to decide who can view and who can create.
Yeah, no update, no delete.
No update, no delete. Yeah.
Okay, good to know. That simplifies a lot. So one more question for you is for myself is, so you mentioned that if a bank were to implement this, each branch would have a copy of the data. So that means each bank also
All branch can view.
will have a mining machine in each branch will have their own node, is it?
Correct. Okay. So here we want to separate the things between a node, a mining machine, and okay. So here sometimes we do mining, but we don't really have a node. So let's say I have a graphic cards and I don't really want to synchronize the whole nodes. So what happened is that I will just link to a mining pool, and the mining pool is the one having the full node, and I just supply my hash. So they will send me a job and say, yeah, this is the transaction, please find the hash. So everyone participate in finding the hash, and then the one that submits the thing is actually the mining pool. So the user itself, the miners itself, is actually not a node. But in these bank cases, they have to be a node. That means they have to have the consolidation of all the files and everything.
I see. So what if means that each branch must have their own node? Why can't the HQ store the nodes while they just access it through the network?
Okay, that can be done as well. So one thing good about blockchain is that let's say if this branch actually have internet connection disruption. So in this case, we cannot tell all the customers that internet down, cannot send money. So if this is not possible, then the alternative is to actually use a node. So you can always create the transaction, but it's not confirmed yet. So when the internet connection gets connect back, they will just resync the whole thing. So this is actually the beauty of blockchain as well.
I see. Okay, good to know. All right, let's move to the next question. The next question is, what's your opinion on rug pull migrated code as certain platforms have them? Is it necessary for such code to exist?
Okay, migrator code is one thing. Upgradable contract is another thing. This tool itself, the ideology is good, but bad at the same time. Okay, why is it good? If it has no malicious intent, it's good. Because let's say I found a bug in this DeFi project. I want to immediately update it. So how can I update it? So if it is an upgradable smart contract, what we can do is we just upgrade the smart contract and patch it. So in that case, ends. And migrator code is used to say that, okay, there's a bug here. So I create a new contract, I migrate everyone over. So in this case itself, the bug is patched immediately. Nobody have suffer funds loss and everything. But here comes the problem. Malicious people will then use this as a way to actually siphon your money out. So for example, you lend your funds to this protocol. And then at some point of time, these developers decided that, hey, let's just remove everyone's money. So they just call the migrator function and then just pull out all your funds to his own wallet. So that is what we call the rug pull. Pull everything out with this migrator code. So I would say that if your function is not very sophisticated, you don't rely on other people, you don't really need to have a migrator code. So for example, like you farming, you're just giving out funds. So in this case, the possibility of bug is very limited. So you don't need a migrator code. But for cases like if you're in Binance Smart Chain, you will see like Auto Farm, you will see Belt Finance. So they have trouble stopping the Venus, causing them to lose money. So Venus did an upgrade to their fee structure, and at the same time, Auto Farm and Belt Finance couldn't really update their codes immediately. So when they put out the notice asking everyone to withdraw their funds out from smart contract, it's already too late. The first one to withdraw maybe suffer very little losses, but the next one that withdraw, the following one, so everyone withdraw will then incur more and more losses. So in this case itself, if you don't have the migrator code, then your funds might be in trouble. But if you have the migrator code, your funds might be in trouble if the developers decided to rug pull. So there's no right or wrong, but I would say it's really up to you whether you want to trust the developer, or if you want to fully don't trust the developer, then the risk is on you. That means if there's a bug, they found a bug, you have to immediately go back to the platform and just remove your fund or do whatever that is being guided. So I think the rug pull code itself, if I were to build yield farming or something like that, I will not have that code. But if I'm building things like yield aggregator or yield maximizer or something that is unknown, that can change a lot, and dependency is a lot, then in that case, we might want to have some sort of emergencies. It can be something that's not migrator. Is it a pause? Is it some form of things to actually safeguard the funds at least? So I hope that answered your questions, because there's no right or wrong in this question. So it's really up to the developers and how the community should think. I just gave you two different views on the same situation. So it's really up to you to decide whether you want to trust this protocol or not.
All right, that's a very elaborate answer. Thank you, Jason. So let's answer two more questions, then perhaps we start with the DevKaki coin tutorial walkthrough thing. Okay, two more questions. Let's see. The next question by the same person. How do you verify a valid coin? If you use a database to verify it, what happens if the database is compromised? How do you prevent that?
Valid coin. Maybe you might want to elaborate more in terms of valid coin. A valid transactions, then I know what you're trying to say. If you're talking about valid transactions, and if you use a database to verify it, I'm thinking that the possible attacks that you have is called the double spending attack. So double spending attack means that I transfer to your platform, and the moment you check, it's already being transferred. But then after you add to the database, you realize that the transaction is already gone, or is being replaced by another transaction. So that's a double spending attack. But you say that if you use a database to verify it as a valid coin, I think the question is not very clear. So maybe if we have a clearer question.
Yeah, I know valid transaction, not sure about valid coin. All right, let's go to the next question then. Any ways to know if an application really adopts private blockchain? Means like maybe, I think what he want to ask here is like, example, you can put the website into a what is it built with? Then you can see it's built with a framework, what is it hosted on, and so on. Can you do the same with blockchain?
So far, we can't really tell if it is really adopting a private blockchain, because blockchain like Hyperledger Fabric and all that, you can Hyperledger Fabric itself will just give you like, you are using it like a database. So when you call the API return you something, but you can't really tell whether the API is calling from the blockchain or not. So that is something that we can't really tell. We can't really see either. But if we look at something that looks like a blockchain explorer, or it looks like there is some immutability in it, then we might be able to tell that it's actually a blockchain. So otherwise, we can't really tell unless they actually publish something for you to see. If they are only an application layer and they just do an API, they can even store it on a database and say they have blockchain technology, and we can't really tell that.
That's true. I can imagine those people just use a typical web app and then they just put in their pitch deck or their poster saying powered by blockchain.
Correct. That is basically what we do if we go to hackathons that no expert is there. They will say, this is blockchain. But the moment we ask few more things, we will know it's not blockchain.
Yeah, that's true. That's why you need good judges to actually drill down to know if there's really a scam or really got implemented.
Correct.
Okay, good. All right, I think we get started with the DevK coin deployment, and then we will end the session with a long Q&A. There's a lot more questions waiting for you.
I think there are a lot. And if I go to the dev kaki and then come back, we can answer them. So let's just do the 5 minutes challenge.
5 minute challenge. Okay.
So this 5 minute challenge itself, we want to deploy the tokens. So if you want to add in like compile time and all that, then that's about 5 minutes. But if you want to explain it, it won't be 5 minutes.
Yeah. Perhaps you do first, then explain. Or
Yeah,
I'm not sure how you're going to do the flow.
Sure. Let me go back to the share screen.
Okay, here you go.
Okay. So here itself, we want to do, okay. So let's continue the slides. So this slide is, I'm trying to choose between the blockchain to actually teach. So I'm thinking that let's do it on Binance Smart Chain, since it's the chain with the most transactions and people is actually looking into it. So just name our tokens name as developer kaki, and then the symbol will be devk, and then let's put it on Binance Smart Chain using the standard of BEP20 and a decimal of 18. So Darren, I think can close the question for now. I'm not sure, I cannot close the question from my side. Okay, thanks. Okay, so the tools that we are going to use is Hardhat. If you are a smart contract developers, I think, can we get anyone that do smart contract here? Okay, for smart contract developers, you might know Hardhat. For those of you that have not done anything, you can look into Hardhat. So Hardhat basically is the environment that allows you to run Solidity locally, allows you to debug, and allows you to look into codes and all that. So previously, before Hardhat, we use tools like Truffle and Ganache. So this tool is the different. So before this, we use MetaMask, Truffle, Ganache. So in today's, we are changing to use Hardhat instead. So we will still use a MetaMask and a Hardhat for this development. So let's go for the tutorial. So in this tutorial itself, just head over to setting up the environment. If you have not done it, just set up the environment, install Node.js and everything, create a Hardhat project. So let's just do this now.
Jishan, I think someone asked, can zoom in a bit.
Zoom in, sure. My screen too
Ultra wide screen.
wide. Yeah, sorry about my white screen. So now can we see better? Okay, so just follow this tutorial. So we will just want to create a new Hardhat project. So let's get started. First, get your Visual Studio Code. So, okay. So let me just make a new directory called devk token. So let's go into the devk token and just run this code, npx Hardhat. Then okay, can I see the words bigger now? So basically just installing the dependency. So in this case itself, let me go through the code that I want to run. So you can choose to create a sample project. So this sample project will give you a few files. So if you don't want to see this, let's go ahead and see this. So they will give you this project structure. Basically, you will have one contract folder, one script folder, one test folder, and then the Hardhat config, as well as the package.json. So package.json will be the things that you need to install. I mean, the dependencies, if you are already familiar with Node.js, this is the dependencies or the package that you install. And then you will have a contract. So in this contract, you will see it as an empty one, or they will give you some empty tutorials. So what happens is that I go to this BSC Binance Chain BSC Genesis contract, then I just copy over the library. So if you don't want to follow this, you can always, I will share the GitHub repo later, so you can just go through everything. So after you do this, just create a sample project. So after you create the sample project, you will see this structure. So I just copy over the BEP20 templates. So the templates itself will give you the library, the IBEP interface. So I have got it here, the IBEP interface. So if you want it to be more secure, you can use this library called OpenZeppelin. So OpenZeppelin is another portal. OpenZeppelin is a project that gives you battle-tested code. So it's being used widely by a lot of developers. So they have already gone through security audits. So they have all these contracts that is already being run through a lot of times, go through a lot of security audits, and is modular, is open source. So in this case, if you want to do a super quick dev Kaki tokens, all we have to do is to import the BEP20 library. So if you want to do BEP library 20, we can do this. Or alternative, we can just import the OpenZeppelin. For OpenZeppelin, you can go to their document, or you can just go here. So you can just go to OpenZeppelin, contract token ERC20. So ERC20 and BEP20 is interchangeable. The name, the standard is the same, just the name difference. So in this case, add a semicolon. Then you can just call your contract name with a constructor, and you are done. So in this case, this code itself will run you the tokens. If you want to end it here, we'll just end it here. But since we are here to learn something, then let's go dive deeper. So this devk tokens is inherited from BEP20. Because this thing is harder for you to read it, so I copied out. So this is the BEP20. So it is ownable, meaning that you can have an owner. So this owner will be able to create more tokens, and then safe math, ensure that when it comes to big number, you don't have any math problem and all that. So you can see that one thing is that there's a mapping of addresses to uint256, meaning that every address should has their own balance. And then every address should allow another address to spend on behalf of them. It's called allowance. So in this case, there's a mapping of address to amount. So let's say I will say address 1. 1 allows, or in this array, address 1 actually allow address 2 to spend X amount of tokens. So this is actually where the allowance work. So if you are in the blockchain space, you will realize that before you do any swap, you actually have to pay. You have to call a function called the allowance, and then after you call the allowance function, then only you can call the swap function. So in this case, you are allowing the smart contract to spend on behalf of you, and that is the purpose of this allowance. So total supply means the tokens, how many supply are there, then the name, the symbol, as well as the decimal. So in this case itself, the constructor is being overwritten by BEP20 to have only the name and the symbol. So they try to make sure that your decimal is 18. Like 18 decimal means if you have $1 USD, you can have 0.17 zeros and then $1 US. That is how small you can actually transfer in terms of USDT. Then you can actually get owner. So this owner will tell you the contract owner. So who can create small token? So sometimes the owner can be dead address. That means nobody can create more tokens. Then the name. The name means the token name, the symbol and decimal and total supply and all that. Okay, so approve means allow someone to actually spend the funds for you, and no, allowance means allows people to spend the funds for you. Approve means you have more than one transactions, you want to approve it. And then transfer from, allow people to transfer on behalf. Then the allowance, decrease, increase, and the minting function, transfer, and all that. So this is a standard BEP20 tokens. So if you want to enable people to burn funds that will decrease the total supply, you should override this burn function in your main address. So here I only have one function that is called mint. It's public. So it has to implement the mint function, the private mint function. So this is actually the full contract that we want to deploy today. So the deploy script is here. So before we go to deploy script, one thing that we want to do is actually to do a test cases. So in this test cases, I want to make sure that the contract works exactly as we want it to. So we use this chai, which is actually a Node.js testing framework called chai. So in this case itself, we want to describe that, okay, we are going to test the tokens. So this is just a name so that you will see from the test cases. Then you can see that get contract factory. So after you compile, you will then have this devk as the contract. Then this devk itself get designers. So this is the helper library from Hardhat to actually get the first address, second address from the mnemonic, and so on. So these are the address from the mnemonic. And then devk.deploy means you want to deploy the contract. So you will have the instance, make sure that it's deployed. Then after that, you will then run this. So should have the right owner. So devk tokens should be initialized the owner to be the owner that actually deploys this contract. So just checking that, making sure that it's correct. Then you want to show the correct name, which is developer Kaki in this case. The symbol, you have to make sure that it's devk. The decimals, you have to make sure it's 18. So in this case, we don't have maximum supply. So we'll just modify this. Okay, and then so should not have any. So total supply should be 0. Okay, just want to make sure that the total supply is 0 when it's initiated. So here we want to test the minting function. So we call the minting function. And then make sure that the balance of is there. And then the should transfer tokens between accounts. So try to mint to account to address 1. And then check that the balance is correct. Then we connect to address 1 to transfer to address 2. Make sure that the address 2 balance is correct. And then should fail if they don't have enough token. So we just try to cover as much test cases that we have to make sure that our contract, once it deploys to the blockchain, there's no way to return unless you deploy a new contract. So these are the test cases that we usually write to try as much as possible before we actually run anything. So this is to ensure that the things can actually go well and don't have any weird things in the when it goes to the actual blockchain. So in this case, the devk project, another project that we just initialized is being created. So let's go to that project. Okay. Okay. Okay, it's a bit lagging here. Okay, let me just quickly get that project folder. Okay, so after you initialize, you will see something like this. Okay, as expected, we have this Hardhat config. So this Hardhat config will just print you the list of accounts. So Other than that, they give you a sample test cases to say just greeter say hello world, then a script that actually allows you to just do this. Contract gets greeter, greeter says hello world. So very similar to the contract that we have earlier. So in this case itself, there's a greeter contract with a string of greetings. Then constructor memory. Okay, so this itself, if you require a string, then you have to call it a memory. So it don't write anything to the hard disk. So it's just loading it in memory. Excuse me a little while. Okay, so in this case itself, we want to replace this with the PEP20 tokens. So, okay, I will just quickly copy from here, which is actually the same if I copy from the website. Oh, never mind. Let me just go with, since we already dissect the contract, so I will just run OpenZeppelin here. Okay, it's getting more than 5 minutes now. Let's quickly do this. Okay, you can use Yarn app or npm install. So in this case, I will use npm install save OpenZeppelin/contracts. Okay, so it's installing. So while it's installing, I will just rename this as devk token, or we just give it the capital name, devk. So here, we want to do one thing. We want to import the OpenZeppelin. Yeah, with Hardhat, you can now use console.sol to actually console log things. Before this, if you were developing smart contract, you can't really do this. So it's quite troublesome to actually debug it. It's quite lagging. Yeah, just copy this. And we change this to dev a token. This is actually a ERC20. And we just have a constructor. And this constructor is just going to have with the symbol of devk. So when we first construct it, we want to send some funds to ourselves. So we'll just call mint. Message.sender means I want to send to the one that actually created this contract. So let's say I just want to send 10, or this one means 10,000. So 10,000 multiplied by 10 to the power of decimals. Okay, so this is actually how you write smart contract code. It's not very far from Node.js, honestly. After we do this, we want to try compiling it. So npx hardhat compile. So this is how it allows us to compile the contract. So it sees that, oh, okay, use a different format. Okay, so when we install the npm, it requires a version of 0.8. So in this case itself, this one is 0.7, so you cannot compile. So in this case, you have to make sure the compiler version is the same. we might have another error. Okay, so this error says that the compiler version of the Solidity is different. So in this case, this one have to change. The hardhat config goes to the hardhat config. Here, there's another one that we have to change. So since it accepts 0.8 onwards, so we just do with 0.8. So if you're able to compile, downloading compiler, compiling it, and now we want to look into how to publish it. Okay, it's already compiled successful. So in this case itself, if we want to run a test case, we can run the test case. So here we want to make sure that, okay, we have chai here. So we want to test the devk token. So it should return that we can actually create it. Should be able. Okay. In this case itself, every single devk is being created the moment we initialize it. And you can never call any functions to create any more. So it will only have 10,000 devk tokens in the whole assistance. And I think I'm going to give all this to Darren after this. Okay, we just deploy without any parameters. Parameters not required. So if it is deployed, you will just expect this devk.name is equals to developer kaki. So we run test case. So the symbol is devk, and the decimal total supply. We are more concerned about total supply. It's actually 10,000. Then you can put in 2, 3, 4. So 18 zeros and 10,000. So this is the total supply that we can expect. Okay, so after we run this, we want to run test. Okay, artifact devk not found. So devk name should be devk. Devk token. So here we put the name devk token. So the artifact have to be called as devk token as well. So it's advisable to put the same name for the contract files and that, so that you don't mess up. And then total supply is not a function, so the S is actually big. It's capital S. So here we want to run the script. So this script itself, we will then just ask devk token to be here, and then deploy it without any parameters. Yep, so we have it passing. So the total supply and everything is correct. So it's very safe to launch now. So let's launch it. Okay. So to run this script, first you have to run you have to add in additional information. Okay, so here if you want to run it, okay, we have to make sure that in our config, hardhat config, we have already stated that what are the parameters we want. So here module exports, we only tell the Solidity version, but what we can add even more is that we can add this. Okay. So I have added this additional information. So this thing over here is to tell that, okay, for default network, please use hardhat. For network testnet, we will use a testnet URL, and then just a random mnemonic that I just generated. And then the hard fork, and then the chain ID, the gas, the fee. Okay, so let's publish it on testnet. For mainnet, I will do it after the session. So if someone wants it, maybe at the end of the session can put in your BSC address. Let's just do an airdrop, even though we don't know what is the value of it, but then we will define the value later. Maybe take it as a ticket to come to this session next time. Okay, to run it, this is the code to run it, npx hard hat network. Then you choose the network and tell them that, okay, I want to deploy for testnet. So just run the script. So this is the script that I want to run. So this script will be sample script. So we'll just call the name as sample script. Sample dash script. Okay, so here we go. Okay, so it says insufficient funds. So here we have to see, okay, why is it insufficient funds? Because this mnemonic has no funds in it. So what do we want to do next is that we go back to this area. We want to make sure that we can get the signer's address. So here, what we want to do is that we can call this, Okay, so we can just say that, okay, give us the owner, and then all the address is here. So this is actually unwrapping. So we'll just await and get the signers. So here, await and get the signer. And then we'll then console log the order. Console log the owner. Okay, so in this case, you will say, you give us the owner address and then says cannot publish. So the owner address is actually this. While we are waiting here to respond, so we can just go to bscscan.com and then look for the testnet file set. Okay, so this is actually the file set. So you can see we don't have enough fee from this address. So from this address, we'll just do this and say, give me BNB, give me one BNB. Okay, funding request accepted successfully. So in this case, we just run the thing again. And this time, we should be able to see a successful launch. Okay, so dev token is officially successfully deployed, and we can now see it on testnet.binance.finance scan BSC scanned. So we can just easily go to search and look for our token address. Okay, so here we go. Developer Kaki devk is officially on the testnet. There will be only 10,000 tokens, and there's only one holder, which is myself. So the moment I created this transaction, so this is actually how we deploy a contract. So this whole contract is already out there. So we can verify all these things, and the token contract is here. So I will publish this whole thing up on a GitHub, and then the link will be shared below. So I think it's time for us to go back to the Q&A. So to answer all the questions, and let me see if there's any questions. Yep. So
Impressive. So now it's on testnet
Q&A.
already.
It's already on testnet, and the mainnet, because I don't want to give out my mnemonics, so let's do it later.
Okay, thank you so much, Yisheng.
So I think this is actually more than 5 minutes because I have to install the package and explain and everything. But if I really just start it and run it, it will be within 5 minutes.
Yeah, so it's definitely possible to create tokens within 5 minutes. So that's why you see there's so many new coins coming out every day. Because actually, if you know what's how to do it, it's actually quite easy.
Correct.
You can start charging companies to create tokens already. Okay, I think before we move from Q&A, thank you for those who stayed until today. Until now, it's been 1 hour and a half. I think before we move on to Q&A, let's talk about Jisheng. You want to promote your company's vacancies, I think?
Yeah, actually, Thrive Academy itself, we are running a blockchain. We are already now on BSC scan. I mean, if you look into a BSC scan, InNet. So we are actually a company that do consultation, do training on blockchain related startups, and we are the main maintainer behind this latest TRVC version 3. I would say version 3. So version 1 was created by someone else. When we contribute, it's already version 2, and then now it's a version 3. So version 3, we are doing it on BSC scan. I mean, we are doing it on BSC as a DeFi protocol that is focusing on NFT and games. So if you like games, if you like blockchain, you like to know more about all these things, we are actually hiring full stack web developers as a start. And then from there, you actually pick up the skills on how to become a blockchain developer. So when you come in, you might be a full stack web developer. After doing for half a year, you would end up becoming a blockchain developer. So we'll do a lot of smart contracts. We'll write a lot of test cases. So this is the day-to-day things that we do. So we are hiring. Go to thriveacademy.com to know more. The website is thriveacademy.com.
Share it in the chat.
I will share it on the chat.
Show it as well.
So we do have some blogs that we try to put up as much information as possible so everyone can learn. So in here, we have a, not to say big team, we are quite small, we are growing. So if you would like to have an exciting journey, feel free to fill up the forms or email me, jisheng@thriveacademy.com. So these two ways, we are hiring web developers that will turn into blockchain developers. That's all for the short pitch. Let's go back to Q&A.
All right. Best sponsor ever that keeps it short, this short.
Yeah.
Okay.
Because I think I have already gone through what we do and all that in the presentation earlier. Yeah. So I think that's sufficient for them to see if they like what we are doing. We are quite agile in the sense that we just use a Trello board and then just keep on changing priorities as DeFi really grows very fast. In 2018, we were talking about script-based blockchain, and then now we are talking about automated trading, talking about liquidity providing, and now NFT. So things change very fast in just 2 years' time.
Okay. So thank you so much for the presentation. Let's continue on with the Q&A. For those of you who want your questions answered or have questions to ask, do stay on. For those who have nothing to ask already, or you can leave the stream if you want to. All right. So we have a lot of questions to go through. Okay.
Really a lot. I'm actually looking at my iPad.
Oh, okay. Let's see here. What's the previous question we left off at? Valid Coin, Hyperledger. Okay. Next question. Do you think fintech companies, okay, this is a good question, use blockchain in managing transactions currently?
Yes, Alipay.
Oh, really? I didn't know that.
Alibaba is the biggest patent holders of blockchain technologies in the whole world, and then followed by Visa and Master. So I think earlier CIMB, HSBC, they are using some sort of blockchain, but only on international transfer. CIMB uses Ripple in 2018.
Oh yeah, XRP, yeah.
Yes.
So Alipay, they use blockchain technology, right? How they made it fast to transfer, to lock everything?
Okay, to make it fast, if you look into Binance Smart Chain, they are doing 3-second one block, and every block is 5 times bigger than Ethereum. So they are doing 14 million transactions a day. So, and that is not still not the full capacity of a blockchain. So how can they achieve this fast? Is because they use proof of authority with stake. So in order to become a validator, they only select 21 validators, but they open for about 50 companies to become their validators. So you don't have to be Binance people. You can be a company like BNB 48 Clubs, and then some Anchor, ANKR, and then BSC Scan. BSC Scan is actually Etherscan. Etherscan is actually run by a Malaysian, but not sure whether he has become Singaporean or not. But some say it's a Singaporean company. So everyone that's big enough can become a validator. They use a predefined, let's say 50 people can come in, and then only the top 21 stake. So you have to stake about 300,000 BNB, which is about 400 per BNB, about a couple of 100 millions, to become one of the validators. And then you will already have your slot. So this block is for you, the next block is for the next person. So 21 will keep on looping. So in this case itself, they can achieve 3 seconds. Every block comes in 3 seconds. So they don't have the uncertainty of proof of work. So that is actually what enables them to be this fast. But I believe Alipay, if they own Alibaba's cloud server and they use their own validators, they can even go for even faster transaction. So I think it's just a matter of time until distributed ledgers or blockchain can reach the speed that Visa and Master wants. That's why they have their own R&D team, keep on having patents. You can see their top patents, more than thousands of them, different concepts, trying to validate this way, trying to validate that way, a lot of different ways to actually work on the protocol.
I see. So just to conclude, you need to be rich to have the BNB enough to stake to become a validator, right? And then second thing is
that is for Binance Smart Chain. There's another one like Matic, Polygon. They also do the same thing. So you have to be rich enough to become that. And in order to do that, they even come out with a DeFi protocol that actually borrows your funds and use it as a validator staking. So if you withdraw, you have to withdraw and then wait for 7 days and they give it back to you. So they only have 100,000. So the another 200,000 is actually community's fund.
I see. And secondly, is a configuration and also the type of proof that you use to make it fast.
Yes, that's what we call a consensus mechanism.
The consensus method, correct. So yeah, because I'm thinking in terms of implementation, if I implement in my future work or whatnot, of course I want to make it as fast as possible, right? So I need to take note of the consensus and to have enough modal to actually deploy the token, right?
Yep. So if you just deploy it on public blockchain, then you just have to pay the gas fee. If you deploy it on the private blockchain, then you have to run the infrastructure. That's it.
I see. Okay, good to know. Next question from Bill. Why does every project require their own coin? For example, is Uniswap, why would someone want to buy Uniswap if Uniswap is just a service to swap tokens?
Okay, that is what we call the incentivized mechanism. So if today you go to a money exchanger, you give them, they say, okay, minimum ticket is 10,000 US dollar with 42,000 ringgit. So after you give me, I say I already put in my shop for 2 weeks, and then I say, oh, nobody exchange, so you only get $5 for 5 ringgit for your interest rate. So in this case itself, it's not very attractive. So what happens is that Uniswap give out their own tokens. So if you put here no customer come, you still get Uni token. So in this case itself, they encourage more people to come in and do the swap. So that creates the value to it. And then when you actually do a swap, a certain percentage of that goes to buy back Uni. So that creates the value for Uniswap token. So in this case, all new liquidity providers, all new liquidity companies or project, they use their own tokens as a way of initial incentivize for people to put liquidity in their platform. So it's about tokenomics at the end of the day, because in public blockchain project, if I just come out with tokens out of nowhere, then you might say that, no value.
So
here itself, they are trying to create the value.
Function or value. Okay, hope that answers your question, Bill. Next question from Eugene. Is CBDC a threat to DeFi? What's CBDC?
So let's Google search what is CBDC so everyone can see what is CBDC. So the central bank digital currency. Okay, so
the screen, you can enlarge your screen maybe.
Okay, so let me just enlarge my screen.
Central bank. Oh, okay.
So
This is what
basically,
China.
every country actually creating their own central bank currency. So I think this is actually not a bad move. It's not a bad move to have a CBDC itself. So if let's say, for example, digital yuan. So digital yuan, if they really comes out and allows people to do a swap, so that itself is actually something that is beneficial to the crypto market. Then we don't have to rely on, say, USDT. Tether don't store all their US dollars in a bank. So what happens is when USDT first came out, they really do a one-to-one pledge. So let's say you have 200,000 US dollars in the bank, you have 200,000 USDT in circulation. But today, they don't. So what have the funds be? There are about 5 billion USDT in the market, but there's only about 2 billion USD equivalent in the whole company. So where does the another 2 billion goes? They goes into bond, they goes into gold, they goes into commodities that raise in value, they goes into things that generates interest rate. And where does all this profit goes? It goes to USDT's treasury. It has nothing to do with us. So in this case, if central bank do it, then maybe we can see that the certain value is being controlled instead of helping one giant like Tether to make more money. So I think it's not a threat, it's a compliment. It helps people to go from fiat into the cryptocurrency world. That's from my opinion. I'm not a financial advisor.
All right. But you're a crypto expert.
Not really lah.
Okay. Right. Next question.
Yes.
Oh, this question. How to launder money with crypto?
How not to money launder with crypto? Okay. I think how to, you can always Google search on YouTube. So we just type how people money launder on crypto. So you will see how the top hackers actually launder the money, how they use mixing services and how they do this. But it's not advisable to do this and do it at your own risk. You might be in trouble. It's against the law. Yeah.
Oh man, why would you ask this on the Facebook Live? It's the SPRM.
Yeah, so you can read it yourself. It's not financial advice.
But yeah, the information is on. Can't believe there's actually articles on this topic telling you how to money launder. Okay, next question from Sol Hussein. Why cryptocurrency is too unstable? How is it controlled? Oh, what? I think why is it so volatile?
Okay. If you ask me why is it so volatile, I would say that one thing. If you see USDT, BUSD, XAUT, all these stable coins are stable, not volatile. So the volatility comes from the investment and the potential of short selling element in it. So everything that can be invested is actually volatile in certain way. GameStop, the GameStop share price is volatile. It can go up very fast. It can go down very fast. Just see a year. You can see, yeah, it goes from here to here. So almost $4 to about 300, and then come back down to 50. So this is the share market. It's unstable because of speculation. So for cryptocurrency, it's unstable in terms of speculation as well. But for USDT, BUSD, and all these things is stable because the nature of it is stable. So for cryptocurrencies, if you really want to invest, not financial advice, people say hold. So it's just like buying gold, buying silver. When people is feeling bullish, they will buy. People is feeling bearish, they will sell. So this is the very nature of cryptocurrency or commodities or things that is tradable. So how to make it more controlled? There's no way to control, because even Forex, even all these things is pretty much affected. If you say regulations can control, regulations can't really control that as well. Stock market, what they can do is to halt it when the price go very big difference. But here, cryptocurrencies, there's no stopping it.
See, good to know. That is something new for me as well. Let's see. Kwek Yao Jing. Anything to take into account during smart contract development?
Do take into account test cases. I would have to stress again and again and again. Do a lot of test cases. If possible, get audit firms to audit your smart contract to make sure that your funds or your contract is bug-free. Think of it like a function that once you deploy, you cannot change anymore. It's not like a web development, you can always change it. You can change it, but you have to ask your community to say, oh, unstick from my old contract, stick into the new contract. So this is not a long-term strategy. For a long-term strategy is to really make sure it's bug-free, is working as expected. So in that case, that is the way to actually move forward.
Okay. So it's a function, a code base that you can't change once you deploy. So you need to trigger it the first time.
So the testing is very important. Use better tested code. So OpenZeppelin is the tools that you want to use because they are a security firm with a lot of contributed codes, and they have been tested a lot of times until almost bug-free. Read for what are the attacks that can happen. If you are a DeFi protocol, flash loan can happen by leveraging and affecting the liquidity. If you are on smart contract alone, reentrancy attack, that means how you use the same transaction, repeat calling it, and raise condition. That means if your transaction is out there, but then it's not being mined on time, so what could happen? So all these things you have to take into account, and you will write a very stable code.
Okay. All right, let's move to the next question. Another funny question by Mingqi. How can how can I legally start a mining farm?
First, you buy a computer like I do. I do have a computer with a 1080 Ti, bought 2 years ago. So basically, just plug your electricity, run the software, double click to run, and then start mining. That is legal as long as you pay TNB lah. If you don't pay TNB, you are illegal lah.
Those that stop lots and steal electricity without break the meter or something, right?
Yeah, so if you want to just mine at home, you can, but it's too hot and you might not want to take the trouble. And then if like a gaming computer, you can always do it at 50% intensity without incurring high cost on your electricity bill. And the temperature is not going to be very high. It's just like you are playing games 24/7. So it's fine.
Maybe in another way I can ask this question is, if I rent a shop lot and then I set up the mining farm and pay electricity, is that considered legal? Or will the authority me? It's legal.
It's legal. Yeah, but
as long as you pay electricity.
Yes, the bill is too expensive that it makes it not viable to actually mine.
Yeah, that's why certain countries is more preferred to mine because electricity.
Correct. Especially some parts of China where they have a surplus of electricity from natural. Yeah, surplus. If you read in China, there are a lot of places like using solar and hydraulic that they have surplus of electricity. That means they can't build. It's too expensive to transfer it to the next town, but the town itself cannot use all the electricity generated. So in this case, just set up a farm there and mine.
I see. Not bad. They reduce the waste of electricity in a way.
Correct.
Okay, let's move to the next question. How does enterprise make sure blockchain is fault tolerant and able to recover from damage?
Enterprise. Okay, fault tolerant. I think this depends a lot. Like if you treat it like a database, your code, how would you recover from this damage is the same on how you recover from this damage. Let's say your database gonna hack, then how do you recover? The case is actually the same with blockchain. But for blockchain, one thing good is that you can always have snapshots of it, and you can't roll back. But like usually when DeFi gets hacked, what they do is that they take a snapshot of how much funds you have before you get hacked, and then compensate back with version 2 tokens. So that is how they actually recover from damage. So that might be something that you want to think from, but it's really depend on case by case. So what blockchain are you using, or what use cases you are using? Then you can see how you want to tolerate the fault. Some like a traditional company will tell you that you have to buy insurance for your code that have problem. You have to run through standard audits. So it's the same thing. In smart contract, you have to go through audit companies as well to make sure your code is bug free. So even there is insurance for blockchain. If you see like Certic and all those audit company, they give you a certain amount of insurance. So you can actually buy insurance in case your smart contract got bugs. They can actually compensate a little bit on with the insurance fund.
Oh, I see. Okay. As you know, code also can have insurance.
Yeah. Big
Alright.
companies usually buy insurance for their code as well.
Right, but yeah, I wonder how can you protect yourself against bad developers or bugs? Okay. So Shen Yong asks, what is your thoughts on smart contracts for law and insurance use case?
Okay, for insurance use case, like I said just now that they already have insurance projects available. You can check it out. They are much more on the codes or the security of the codes and all that, not the insurance like life insurance, medical insurance and all that. But I wish that if one day one project can come out and do, but then that itself will have to be heavily regulators will not like you using this because you are actually using the money out and all that. So it might be a little bit hard for this case. For law, if we are able to set up a GitHub for lawyers to actually put in their law, and every time they amend law as a GitHub commit, I think that is already good enough. But then if they can't even accept that, I don't think they can actually accept blockchain. So one point of time, they might actually change the law book instead of following a book. They put it digital, but I don't think it will be things that come so soon. What I'm thinking is that if there's a repository of changes for every single law book or every single article, I think that's already very good enough. But now they don't even digitize it in that level. I think it still needs some time until we see good changes in that particular segment. But for traceability of product and all that, I'm seeing it coming soon. Like LVMH is coming in and all that. So that means traceability of goods and services is already coming in. So law and insurance is the one that is usually regulators have to look into it heavily. So not so easy to come to blockchain or smart contracts in this case.
So luxury goods are the ones starting now, logistics, digital passports, health passports, right?
Vaccine passports.
Okay. So that means like what? Malaysia and all the other countries gonna use on a central on a blockchain.
Proof of authority, private blockchain. That is only the authorities can have an address to actually publish, but then everyone can actually verify it.
So it's using the same network, is it?
Yeah. Supposedly.
So will it be private or will it be on some sort of existing protocol?
I don't think it will be on some sort of existing protocol, because if it is on existing protocol, then malicious people can actually pay a lot of funds to see how to revert transactions. It should be on a private and a proof of authority network.
I see. Interesting. Yeah, because I see that's coming out soon, and perhaps that's how we're gonna get the travel.
Yep. So I think it will not have a single network for every single country, but it might be few country comes together one network, and then maybe one country, that country alone do one network.
Okay,
Might be the case.
network. All right. Okay, for NFT, how do we prevent illegal distribution? I don't think you can do that.
This is actually the same way you prevent fake DVD and fake movies, audios out there. So for NFT, yes, you can copy my image 1,000 times, 1 million times, but you can never prove the ownership of that picture, because essentially it's just a JPEG. So if I just right click save image as, I can just copy the picture away. But the ownership, if I am the designer, I put this art up as an NFT, my address will be the creator. And this will be the only one that I'm creating. So anyone else that creates is fake. So no matter how you copy Mona Lisa, it will not be the same Mona Lisa's picture that you have. So if you want how to prevent illegal distribution, just sue them like how you sue them if it is a pirate DVD. It's hard, but then it's possible.
Yeah, so actually people buy these arts and everything is basically to say I own it, not that I have it. I mean, not the physical object or the digital object, but the proof that I own it. That's the thing they pay so much for. Okay. All right. Next question. I am new to smart contract development. I've been using Truffle. Now that you mentioned Hard Hat, does it have any advantage or is it an industry standard?
Okay. Truffle and Ganache is the one that we used back then. Okay. One thing different with Truffle Suite is actually the cloud version that allows you to do a lot of automation stuff and all that. But I think at some point of time you have to pay. So Hard Hat is actually the alternative that a lot of people use. Hard Hat replaced Ganache in the sense that you can just run NPX Hard Hat. It will create the blockchain, allows you to actually dry run everything. But in Truffle, they only provides you the area to write codes and test codes. They don't have the full-fledged. So most of the developers of smart contract now move into Hard Hat. But still, if you are the developers that go in on 2018, you might still stay with Truffle. I stayed with Truffle until this year. I just switched to Hard Hat. So far, I think Hard Hat is more, there are more things come together, works better with Open Zeppelin, but it's easier. I don't have to install so many things. If I have new stuff coming in, I can just say, oh, install Hard Hat with NPM, and everything is already there. But for Truffle, Ganache, and all that, Ganache you need to install with the DMG file. That means you have to download the application or exe file, then install it, then just to run it. And then you want to run Truffle, you have to install different libraries. So a lot of libraries to install. It's a little bit annoying, but then it's actually usable. But I would prefer Hard Hat for my new stuff that just came in, then easier for them to get on board. So it's just a personal preference and not really an industry standard, I would say. Just that more new developers prefer Hard Hat for the simplicity of installation.
So yeah, just use the latest technology. You won't go wrong with that.
Yeah. Since most of the YouTube and all those is from there as well.
Okay. All right. Next question from Clarence. What's the best way to look for bugs in smart contract? I think just you mentioned, right, Zeppelin.
Yeah. Use battle-tested Open Zeppelin codes, and to find bugs, you have to think of all possible ways that things can go right and all possible ways that things can go wrong, and then write a test case for it. So like just now, the example of their developer kaki tokens, I just go through it and make sure that it should not send if they don't have the token. It should send if they have the token. After sending, must make sure that they have. So you have to think of many different ways. You have to try, let's say if I want to send a maximum number, we have overflow. So make sure that you use safe math correctly. You want to test every single possible things. So I think that's the only way you can find bugs. In fact, if we can adopt this ideology in web development, I think we can save a lot of debugging time. But it's not so easy to write every single test cases. It requires a lot of work. It's harder to write test cases and quality assurance code than to actually create the API in the first place. So to prevent bugs is just to use a well-tested code. Code that actually already out there for quite some time means well-tested. Then write a lot of test cases. That's it.
Okay, so if you want to learn more about this, you can search for test-driven development.
TDD.
Yeah. Okay, next question. For proof of stake, does burn coins still count as stakes in the network? If they don't, is there a chance for 51% attack to happen anytime there's a huge amount of coin that is burned?
Okay, proof of stake. Okay, so first thing, we have to dissect it to know what is 51% attack. 51% attack means someone controlling 51% of the network. That means if your hash rate, okay, let's go to proof of work cases. If your hash rate is 1 terabyte, that means all active machines is generating 1 terabyte. I mean, 1 tera hash. So you have to control another 1 tera as a malicious attackers to make changes to this. For proof of stake means you have to be an active staker. So in this case itself, the coins that is already burned cannot be an active staker. So how can they be counted as part of the 51% attack? Only the active staker will be counted. So in Binance Smart Chain terms, there's 21 valid people with 300,000 BNB stake. So if you want to do a 51% attack, you have to be 400,000 BNB stake. Then maybe you can win But because of the authority parts, you cannot do that because you have to be the top 50 that is shortlisted before you can even stake. So in this case, you can't really do that. But for those purely proof of stake, you can, but you have to own more active coins than the active validators. So it's not about the 51% of the whole network. So it has nothing to do with the burn coins. It's about the active stakers. So it has nothing to do with the burn.
Okay,
Hope
wow.
that-
Again, this is something new. Thank you for explaining so detailed on this. Yeah, I guess it's a lot of things to absorb tonight. I think
Yeah.
we'll end the Q&A here. It's 10:10 already. Wow, this is the first time, I guess this is the first time I've seen a talk able to answer all the questions in the Q&A. Okay, this is very, very, thank you so much to Jisheng for the talk tonight. 2 hours long, it's not easy. So thank you for your effort. I think today you've inspired at least got 60 very committed blockchain people now.
Stay until the end.
Yeah, that's very impressive. There are 60 people still staying with us right now. So everyone, thank you for joining us tonight, and hope you learned something new. Okay, up to date with all the new latest developments in blockchain ecosystem, and hope you guys can carry on your own learnings and everything, and hope it helps you to land a job or get projects in the future. Okay, so stay tuned for the upcoming session. If there's any requests, just post in the Overgaki. I will try to find the expert for that certain topic, or find some certain topics that will benefit you guys in the future. Okay, thank you so much for joining us, and see you next time. Bye.